Let's solve an easy Putnam variant. So this over here is a really popular integral, and we have to make some tricky substitutions. Let's say x equals tan theta, and this simplifies, yeah. And then we also have to use some other King's rule and such stuffs, yeah. And this is a really tricky problem, and it's also popular on YouTube right now. And you can find one of the nicer solutions by Bree the math guy, yeah. And this appeared in Putnam in 2005 A5. Now let's solve a slight variant of this problem, where instead of x we have, so instead of n plus 1 plus x we have x, yeah. And this one is not too hard as like this, but the tools this uses is the beta gamma function, yeah. So that's why for this you don't need a beta gamma function, but for this one you do need such tools. Now how do we begin solving this problem? First of all, we note that since x square, since the value of x is going from 0 to 1, the modulus of x square will be less than 1, and also the modulus of negative x square will be less than 1. Now, since we know that 1 by a minus 1, a by 1 minus r, this is a formula for infinite geometric series. Here also we can apply infinite geometric series formula, and using that we get integral from 0 to 1 ln of x, and then sum from n equals to 0 to infinity minus x square to the power n dx, and now after we take this constant inside the sum, and from dominant convergence theorem, if we interested in sum and integral, we have sum from n equals to 0 to infinity, integral from 0 to infinity minus 1 to the power n x to the power 2n ln of x dx, yeah. Now after this, this one is a standard integral, and that can be evaluated by gamma function. If we have integral from 0 to I think this is not from 0 to infinity, from 0 to 1, sorry, I'm sorry for that. 0 to 1, yeah. Okay, now integral from 0 to 1 of ln x to the power n x to the power m dx. This integral is equal to minus 1 to the power n, and then gamma of n plus 1 by m plus 1 to the power n plus 1, yeah. And so using this formula we can solve this one. We get sum from n equals to 0 to infinity minus 1 to the power n, and then from this we have minus 1 to the power 1, and then gamma of 2 by 2n plus 1 whole square, yeah. Now we can try to take minus 1 outside the sum, and this is sum from n equals to 0 to infinity, gamma of 2 is 1, so this is minus 1 to the power n by 2n plus 1 whole square, yeah. And now this is a well-known sum of like assigned to Catalan's constant. Our Catalan's constant g is defined as this constant 1 minus 1 by 3 square plus 1 by 5 square minus 1 by 7 square. This sum over here like converges to a value, and that value is known as g, yeah. And so this is just minus of Catalan's constant. So this was this integral, just changing to infinite series using a beta gamma function formula, and we got the infinite series, which is the answer. So that was it. Thanks for watching. I hope you enjoyed the video. Also try other problems from Putnam, they're really nice, and hope to see you in the upcoming videos too.